In 2008, a groundbreaking event occurred. A man was successfully cured of HIV. This marked the first, and so far, the only instance of such a cure in over 70 million cases of HIV worldwide. While this achievement is remarkable, we still don't fully understand how it happened. We have managed to cure diseases like malaria and hepatitis C. So why is HIV still so challenging to eradicate? To answer this, we need to look at how HIV infects the body and progresses to AIDS. HIV, or human immunodeficiency virus, spreads through bodily fluids. Common transmission routes include unprotected sex and sharing needles, but it cannot be spread through the air, water, or casual contact. Anyone, regardless of age, gender, sexual orientation, or race, can contract HIV. Once inside the body, HIV targets the immune system's helper T cells, which play a crucial role in fighting infections. HIV is a retrovirus, meaning it can integrate its genetic material into the DNA of these infected cells, turning them into factories for producing more HIV. In the initial stage of infection, HIV replicates within these helper T cells, destroying many of them. This phase often presents with flu-like symptoms but isn't usually fatal. Over time, the virus continues to multiply and destroy T cells, leading to a stage where the immune system is severely compromised. When T cell levels fall too low, patients become vulnerable to infections that a healthy immune system could typically fend off. This advanced stage is known as AIDS, acquired immunodeficiency syndrome. Fortunately, there are effective medications available that can manage HIV levels and prevent T cell counts from dropping to critical levels. Antiretroviral therapy ART allows most people with HIV to live long, healthy lives and reduces the likelihood of transmitting the virus to others. However, there are two major challenges. First, patients must adhere to their medication regimen for life. Missing doses can allow the virus to rebound. These drugs work in different ways. Some block the virus's ability to replicate its genetic material, while others prevent the virus from maturing or assembling, thus stopping it from infecting new cells. Despite these advances, HIV can hide in the DNA of healthy T cells where our current treatments can't reach it. Most T cells die soon after being infected with HIV, but a small number retain dormant HIV genetic material for years. This means that even if we eliminate all active HIV from an individual, these latent cells can reactivate and start spreading the virus again. The second major challenge is access to treatment. In sub-Saharan Africa, home to over 70% of the world's HIV-positive population, only about 1 in 3 people had access to antiretrovirals in 2012. Political, economic, and cultural barriers complicate effective prevention and treatment. Even in the US, HIV still causes over 10,000 deaths annually. Despite these hurdles, there is growing optimism. Researchers are exploring several promising approaches. One involves using drugs to activate all cells that harbor HIV genetic material, which would expose and destroy these cells, making them vulnerable to current treatments. Another approach is using genetic tools to remove HIV DNA entirely from the cell's genomes. While having only one known cure out of 70 million cases might seem discouraging, it demonstrates that a cure is within reach. This progress gives hope that we might eventually conquer HIV for good,